Okay, now we'll talk about important concept of MongoDB called as replication, by which it provides something called as high availability. While discussing the CAPS theorem and features about MongoDB, we had discussed that MongoDB compromises on consistency and provides high availability and high partition tolerance. So this is the concept called as replication, by which MongoDB provides this high availability. Now let's exactly try to figure out how exactly MongoDB uses this application to provide high availability. So what MongoDB has is, it will have one MongoDB server. So we'll call this as a primary server. Okay, and it will have some subordinates, secondary MongoDB servers. And as usually have our application server, which will do all the write and read operations on this server. So this is my application server. Okay, and now everybody would be connected to one another. For the time being, let's keep this one directional. We'll see the other direction. One directional means whatever write operations are to be done, the application server will always do the write operations on the primary MongoDB server itself. Okay, where it can perform the read operations, we'll have a look at it later. But as of now, whatever write operations are to be done will be done in this primary instance at itself. Okay. So now what happens? The application server does some write operations on the primary MongoDB instance. As soon as this happens, what the primary server will do is, it will create something called as an oplog. Oplog is nothing but operation log. Oplog is nothing but operation log. So in a sweet sense, the MongoDB primary server will log all the operations, all the write operations that are performed on its dataset. Okay. As soon as it does this, as soon as it creates or modifies this oplog, the secondary instances will copy this oplogs. Okay, the secondary instances will copy these oplogs and execute it on their own dataset. They will copy these oplogs and execute on their own dataset, so that they have the same dataset as the primary instance. So that they have the same dataset as the primary instance. With this, they make sure that each of these three servers share the same dataset. With this feature, they make sure that each of these three servers has the same dataset. Okay. Now, this primary and secondary servers, they constantly keep on talking with each other with something called as heartbeat. Like for example, hey Sachin, are you there? Sachin, are you there? Sachin, can you please talk to me? Are you there? See, Sachin is not responding, right? Why? Because Sachin is not there. If Sachin would have been there, he would have responded to my request. This is called as sending of heartbeat. So in a similar way, the primary and MongoDB instances, primary and secondary MongoDB instances, keep on talking to each other with something called as heartbeat. Now, if any one of this instance is not able to reply for a specified interval of time, then that instance is considered as dead. That instance is considered as unavailable. And if that instance is the primary instance, if that instance is the primary instance, then the secondary who came to know that the primary is down will trigger something called as election. The secondary who comes to know that a primary is down will trigger something called as an election, and based on some criteria, one of the secondaries will win, and whichever secondary wins will become the new primary. And this entire process of election and electing of a new primary and the secondary becoming the new primary happens within a fraction of a second, and that's why you never have a downtime and you always have your database available. And this is how high availability is achieved with this concept of replication. This is clear? Okay. Now what happens? Now let's see where the read operations are going. Now based on some configurations, you can make your secondaries available for read operations. You can make your secondaries available for read operations. So let's have a look at the features and configurations of the secondaries. So first thing, there can be a maximum number of 11 secondaries in a replica set. Now what is a replica set? This is a replica set. Okay, so let's draw it. Wait. So this is called as one replica set, and the entire replica set maintains the same set of data, and we have seen how they do it, right? So there can be maximum number of 11 secondary MongoDB instances in a replica set. Now, the secondary instances can be configured as a priority 0 replica set or priority 0 replica set member, or it can be a hidden replica set member, or it can be a delayed replica set member, or it can be an arbiter. Okay, now let's look at what exactly this is. So priority 0 replica set member means it can never become a primary. It can never ever become a primary. The reason is As I said earlier, that based on some considerations during the election, one of the secondaries wins at the elections and becomes a primary. So first, let's have a look at what exactly the considerations are. So one of the most important consideration is the priority. Okay, priority of the secondaries. So basically, the admin is a person who will define the priorities of the secondaries. So this decision will be completely based on, the admin would be aware that which server is the strongest and which server is the weakest. So based on this, he will make a judgment that, okay, if my primary goes down, then the next powerful server should become the primary. And that's why he will keep the priority of that next powerful server as the second highest. Second highest means one lower than the actual existing primary. And then in case the existing primary goes down, this new the secondary with the second highest priority will become the new primary. So this is one criteria. The second criteria is the oplog. So it also depends on what amount of oplog from the primary is being copied by the secondary. If we have a tie on the priority, then this oplog part is taken into consideration, and this ensures that the new primary has most of the old primary's data set. So the secondary which has the maximum oplog wins the election. Next is uptime. For how long the server was up, means for how long the server was on from the last shutdown. Okay, so whichever secondary has the maximum uptime has a better chances of winning the elections. So these are some of the criteria in which, based on which a new second primary is appointed. And one more is the network proximity. So what is this network proximity? It is like, see, I can have this condition that I have my primary and some secondaries in India, and I have some secondaries in US as well. Okay, so basically they share same kind of a data, but for my US users, I have a database there in US itself, so that so much of network is not traveled from US to India. That's why I have a server at US, and I have a server in India as well, because majority of my users are in India. So I'll keep the primary as well as some secondaries in India. So if the primary now goes down, then first the Indian servers will get a chance to become the second primary. First, the Indian secondary servers will get a chance to become the primary, and then the American servers will get a chance to become the primary. Why? Because these Indian servers are close to the primary which just went down. Okay, so this is network proximity. So now coming back here, the secondary instances can be configured as priority zero replica set member, in which it means that it can never become a primary. It cannot trigger elections. It can be a part of elections, but it can never trigger elections. It is also known as a cold standby. Means this kind of secondary server can be used as a cold standby. Like if you lose your data, everything, and you don't have a chance of getting a new server set up as primary, then you can always have an option that, okay, bring some new servers and establish everything again, and then take this data from this priority zero replica set member. Okay, then you have something called as a hidden replica set member. This hidden replica set member is more like an arbiter. So what is an arbiter? So what is an arbiter? In case you have even number of secondary instances, in case you have even number of secondary instances, then during elections you won't get a majority. During elections you won't get a majority, and so your new primary won't be decided. That's why what you always do is, if you have even number of secondary MongoDB instances, then you deploy a very simple server which is called as an arbiter. This server is there only to vote in elections. This server is there only to vote in elections, and it cannot do anything else. It can just vote in elections. Okay, so this is one part. So the hidden replica set member is an arbiter with authority to copy the primaries of logs. Okay, so he can vote in elections, he cannot become a primary, but he has the option authority of copying the primaries of logs. Okay, now so this kind of a replica set member, it would be used to balance workloads. Means what? Now what we will do is we will tell the application server that whatever write request you have to do it on primary instance, but whatever read request you have to do, you can do it from the secondary instance. So whatever read request is, it will be redirected from these secondary instances. And that's why it can be useful for taking off some workload from the primary. So now the primary won't be harassed for read operations. The secondary will help in the read operations. Okay. Next one is a delayed replica set member. This is similar. It is similar to a hidden replica set member with only one difference, that it will copy delayed data. Means what? For example, we have seen this, that we don't have atomicity, means all or nothing architecture is not there. So if like 8 operations out of 10, if a job has 10 tasks and 8 of them are completed, okay, then I have an option to come back and resume from the ninth one. Okay, but now what if I don't want the 8 task? What if I realize that all my 8 task has kind of made my data inside my database bad, and now I want to do a big rollback of all these 8 tasks. So there is no option of doing such a big rollback. So in that case, what we'll do is we'll make use of this delayed replica set member. So this delayed replica set member would be configured in a way that it will not immediately execute the oplogs of the primary. It will copy the oplogs of the primary and keep it as it is for a specified duration of time, and after that duration of time it will execute it. Means like, for example, if I knew that okay, these 8 operations are going to take some time, so I'll be configuring as do it after 5 hours. So if something goes wrong within the 5 hours, I don't have to worry. I can always have 5 hours old data from this delayed replica set member, right? So it is used to get old data, or I can say that it is used to get the old snapshot of the server's data set. Okay, so this is how they can be configured, and this is how your replica set looks like, and these are some of the properties of your replica sets. And due to this feature, MongoDB ensures high availability. Okay, now let's try to set up your own replica set environment. Okay, now what we have to do is we'll be playing with this replication and we'll be setting up our own replica set environment. So let's go to our console, and there let's first become the root user. So I'll say su, and the password is I've made a mistake in the password. So I'll do it again. Okay. So now I'm the root user. So now what we'll do is we have to start. This is a same one single machine. We don't have separate servers. So we'll be starting different instances of the MongoDB server on the same machine. So what we'll do is we'll create different data paths for the different MongoDB servers, and we'll configure and start each of the separate MongoDB server for these separate data paths. Like earlier we were doing it like starting MongoD instance from db path slash var slash lib slash mongo, right? So now what we'll do is inside var lib mongo itself, we'll create more folders, and then we will start it like MongoD, then db path would be var lib mongo, and then server 1, var lib mongo server 2, var lib mongo server 3, and we will start each of these servers on different port numbers as well. So the default one is 27017. So we'll start one on 27017, one on 20718, and next on 27019, and something like this. Okay. So now let's first go to that location. So I'll say cd var lib mongo. Now here I'll create the three directories. I'll say mkdir make directory, replica set 0, make directory, replica set 1, make directory, replica set 2. Okay. Now we will start our all the three MongoDB server instances. So what we'll say is we'll say MongoD. The port number where we have to start is 27017. The DB path is slash var slash lib slash mongo slash replica set 0. Okay. Then we will say that whatever logs happen, whatever logs are created, please log it in or please dump it in this location. Var lib mongo replica set 0 slash log. Okay. MongoDB will by default automatically create this log folder, so you don't have to worry about creating it. And then we'll say that this particular server will belong to the replica set by name my replica set. So this is a name that we have given to our replica set, my replica set. So you can give any name that you want. Then we will say use a property called as fork. Fork means this is a property which will let this service run in the background. Okay, this MongoDB server instance will run in the background so that we can do whatever we want to do in the foreground. Then we'll say make use of small files. Make sure that the file sizes are not too large because we are doing on the same machine. And because we are doing in the one single machine and this is not a production deployment, so we don't want any backup or we don't want any journaling. Okay. So this gives us a confirmation that the child process has started successfully. Now let us start the second and third one as well. So we'll say MongoD. We'll give a different port number this time. Earlier we had used 27017. So we will say let's use 27018 this time. So the DB path this time would be slash var slash lib slash mongo slash replica set 1. So we have used 0. So now we'll use 1. Then the log path will be slash var slash lib slash mongo slash replica set 1 slash log. Then we'll say that even this guy belongs to the replica set named my replica set. Now just keep in mind one thing, that this name should be the same for all the servers that you want to include in one replica set. So you should tell them that okay, you all are a part of one replica set by name my replica set. Okay. Next again we'll say fork small files and no journal. So again, it says that a new process has been started with the process ID 3498 and the child process has started successfully. So now we can start our next, configure our third server. So we'll say again MongoDB. This time we'll use port number 27019. The DB path would be /var /lib /mongo /replica set 2. Then the log path would be /var /lib /mongo /replica set 2 /log. Then the name of the replica set to which this belongs is the same, my replica set. Then we'll say fork small files no journal. So now the process ID is 3524 and the child process has started successfully. Okay. If we wouldn't have given this fork thing, if we wouldn't have specified this fork operation, then we would have to start 3 different terminals and start these as a foreground or a continuous running process on 3 different terminals. And for whatever operation we will do now, we will have had to do it in the fourth terminal. So it would have been like in one terminal one is running, in one terminal the other one is running, in the one terminal the third one is running, and in the fourth terminal we are doing all the operations. To avoid handling these many terminals, what we do is we have told them that okay, all 3 of you run in the background. Okay. So now what we will do is we will log on to the first one of our servers. We will log on to first one of our servers and we'll start the initialization of our replica set. So first we will get out of this and go to the root directory. And now we don't have to be the root user, so we can become the wisdom user again. And now we'll say start a client. Okay, now we'll say start a client on port number 27017. Means what? Now a server is listening on port number 27017, right? The first server out of the 3 created. So this client will go and establish a connection with that server which is listening on port number 27017. Okay, so now this is started. Now what we will do is after this is started, we will initiate our replica set. So the command for initiating a replica set is rs.initiate. So this is a JavaScript method for your MongoDB by which your replica set would be initiated. The replica set by name my replica set would be initiated. Okay, so it is saying that configurations are now saved locally. No explicit configurations were specified, so it is creating a default one. Okay, and the name of your server is localhost.localdomain, which is running on a port number 27017. So now a new configuration file has been saved locally, which it created here, and it should come online in about 1 minute. Now if you press enter again, you will see that the name of your replica set is my replica set, and this guy is the primary now, because this is the first one who initiated the replica set, so he's the primary. So this is supposed to be, in a production deployment, this would be your strongest server from where you will initiate your replica set. Now you have only initiated your replica set, but you have not added members to it, right? So now what we will do is we will add members to our replica set. So the command for adding a replica set member is rs.add and the name of the server. So here, make sure that you use the proper names. So if this would have been a production deployment or it would have been a server, then it would have been the IP address of the server. But here it is localhost at local domain. So we will use localhost.local domain. So we know that all three servers would be having the same name, only the port number would be different because everybody is on the same machine. So we will say localhost dot local domain, okay, and the port number is 27018. Okay, so it is giving us a OK acknowledgement, means one server is added. Now we'll do it for the second one as well. So we'll say, let's first clear this. Now we'll say rs.add localhost dot local domain 27019. Now in this process, make a note of one thing, that if you are using three different machines, then in that case, if you are using IP address of one machine, then you should be using IP address of all the machines. If you are using host name of one machine, then you should be using host name of all machines. It should not be the case that for some machines you are using the IP address and for some machines you are using the host name. This will create a confusion for the MongoDB replica set and configuration, and this will not happen in the proper way. Okay, so if you are using a host name, then everywhere it should be host name. If you are using the IP address, then everywhere it should be the IP address. Okay, so now again we have got the acknowledgement message, means our second one is also installed. Second member is also added in this replica set. Okay, now let's check out the status of our replica set. So we will say rs dot status. So now you can see here that your localhost.local domain port number 27017 is your primary. Localhost.local domain 27018 is the secondary. And localhost.local domain 27019, the third server that we started initially, is your secondary. Is clear? Okay. Now in this, health 1 means it is live. Okay, so there are different integer values used to specify health, like whether it is active or whether it is not active, whether it is dead. So this is the information that an admin would be interested in, to find out the health status and everything of the secondary instances and all the servers. Okay, so after doing this, what we'll do is we'll check the configuration of our replica set. So we will say rs.conf. So now you can see here that the name of your replica set is my replica set. The version is 3, means this has been modified 3 times. 1, when you added the primary and initiated the replica set. 2, when you added the first secondary. 3, when you added the third secondary. Now if you'll add more secondaries or you'll make any changes in the configuration, the version number will increase. Okay, so this will give you an idea of how many times the configurations or something has been changed in the replica set, or how many times the configuration of the replica set has been played with. Okay, so this can be used for auditing by the administrator. So in this, now you can see that you have 3 members with ID 0, 1 and 2. The member 0th member is your 27017, first member is 27018, and second member is 27019. Okay, now what we will do is we will log out from, we will exit from this primary, and we will go to the secondaries and we will check the status and configurations and see that everything is same there as well. Okay. So we will say exit. Make sure that you are not shutting down the server. You don't have to shut down the server. You only have to exit from the client. Okay. So now we'll say Mongo. Port number is 27018. Now see, it is giving secondary. Now if you do rs.status, you will get the same status. If you do rs.conf, you'll be able to see the same configurations. Okay. Now if to exit from this guy also and go and log in your third server, which is port 27019. So this is another secondary. So here if you do rs.status, again it is the same, and here if you do rs.conf, then again this is the same. So this gives you a confirmation now that your replica set is properly initiated. Your replica set is properly initiated and the primary and your secondaries are running properly. Okay. Now let's exit from here as well. So now what next? We have successfully set up our replica set environment. Now let's see what happens when a primary goes down. Let's see what happens, how the election is triggered at the backend and how quickly it happens and the new secondary is appointed as the primary. Let's have a look at that. Okay. So what we'll do is we'll first log into the primary server and make some changes in the configuration. So for making changes in the configuration, we'll save the configuration to a variable called as config, so that we can use it in the later part. Okay. And now what we will do is we will assign priorities to each of our primary server. Why priorities? Because we know that the one with the second highest priority, the secondary with the second highest priority, is the probable one to become the new primary. In case of a failure of the existing primary, the secondary with the highest priority will become the new primary. So what we'll do is we will manually decide who has to become the new primary. So we will assign the priority for each of these servers. So what we'll do is now we'll say config. So this is the variable where we have stored our configuration dot members. So when we had a look at the configuration, like for example, see this again, rs.conf. So you can see that we have a key called as members into it, okay, which has this document, this array of subdocuments. Okay. So now what we have to do is we have to access this key. So we will say config dot members, and we have to access the 0th element, means the 0th MongoDB server or 0th replica set member, and we have to set the priority property of this 2 3. So this has to be maximum so that this remains the primary. So this is done. We'll do it for all the remaining ones as well. So we'll say config dot members, the first one, dot priority is 1, and config dot members 2 dot priority is equals to 2. So what we are doing here is, for the server running on the port number 27019, the second member is the server running on port number 27019. So we are giving it the second highest priority. So if our primary goes down, the server on 27019 should become the new primary. Okay. Okay. Now once this is done, we will reconfigure our replica set. So we will say replica set dot reconfigure it using the variable config. Okay, so it is saying that this is normal. Don't worry about this. This is normal. This is what is important, that you get an OK message, and it has reconnected to a server after the rs command, and this is normal, so you don't have to worry. Okay. Now let's view our replica set configuration, the new configuration. So we'll say rs.conf, and now you can see that the version number has changed because one more modification has been done, and everybody is getting the priority now. So the priority of this guy is not given because it is anyways 1, which is by default. Okay. Now we will just have a look at the confirm the status of our replica set. So we will say rs.status. So see, this is secondary and running properly. This is secondary running properly. This is primary and running properly. Okay. Now we will exit from the primary, and we will kill our primary instance. So the process on process number we got initially, right? That the MongoDB server running on 27019 is running at the backend with some process number. So we'll kill that process. But we don't remember that process right now, right? So what we'll do is we'll list all the active processes and then identify that process which is having the 27017 wala MongoDB server, and we'll kill that. So for killing a process, what we'll do first is we'll become the root user. Now we will list all our processes. So we can list it using a command processes, the active ones, and don't get a list of all the processes because a number of background processes would be running. So get only the processes that resemble to the word Mongo. Okay, so we'll get only MongoDB processes. So you can see here that 3 of our processes are running. So one is running as with the process ID 3473, 3498, and 3524. Out of this, the primary is running on port number 27017, means this is the process ID 3473. So now what we will do is we will say kill this process with the ID 3473. Okay. Now if you run the same command of getting all the processes, now you can see only 2 MongoDB servers are running in here. Okay. Now what we will do is we will log into the server, both the servers, and see what has happened. So we'll say Mongo port 27018. So no change has happened. This is a still secondary. So let's exit from this guy. You don't have to be root, so you can exit it from the root as well. Now we'll go in the third one. So we'll say Mongo port number is 27019. Now if you can see that this guy has become the new primary because it had the second highest priority. So this guy became the new primary. Okay. Now if you check the configuration and status, you will see that it has 3 members and nothing has changed with the priority and stuff. But if you go and see the status, you will see that there are 3 members, but the health is 0, means this server has gone down. It is not reachable or it is not healthy, right? And that's why this guy is still the secondary, but now this guy has become the primary. Okay. Now what we will do is we will exit from this guy, we will exit from this secondary, and we will restart our primary, means the old primary which was there, which we killed it. Now we will restart it and then see what happens. Okay, so let's first exit from this guy. Now what happened, my admin did some, admin came to know that the primary server is down, so he did something into it and he kind of brought that primary back. Okay, now once the primary is back, that server has the highest priority, right? He was assigned the priority as 3. So what he will do is he will quickly have a word with the secondary servers and he will copy all the oplogs from the new primary and he will make his data set equal to the new primary, and then he will trigger an election, and because he has highest priority he will win and he'll become the primary again. So let's try out that now. Okay, so now what we have to do is we have to bring the primary back. So what we will do is we will just remove the lock which is put on because we killed it. So what we'll do is we'll say remove /var/lib. First we'll have to become the root user for that, so we'll say su. Okay, now we will go to that location where our MongoDB, all the 3 directories are. So we'll say cd /var/lib/mongo. So we have to do a remove. So we'll see replica set 0 MongoDB.log. So it will ask whether are you sure that you want to remove the lock. So say yes, I'm sure that I want to remove the lock. Okay, now the lock is removed. So what is this lock? This lock is like, this was in use. Okay, so now whatever configurations we had done for it earlier were still there. Okay, but it was killed. Okay, so what we have done is we have removed the lock. Now what we will do is we will restart that process. So we'll say MongoD, port number is 27017. The DB path is var lib mongo replica set 0. The log path is var lib mongo replica set 0 log, and the replica set to which it belongs is my replica set. And again run it as a background process. Make use of small files, and we don't want any journaling. Okay, so this guy has started with the new process ID now. Okay, now what we can do is don't have to be this thing now, and we will start a client on that port number. So we'll say Mongo port 27017. Now if you see, this guy has become the primary again. Now if you do rs.conf, you'll be able to see that nothing has changed here. But if you do rs.status, you'll see that this guy has again become the secondary and this guy is the primary with his health proper now. Okay, so in this way, the elections are triggered, and this happens within a fraction of a second. And because of this, your MongoDB ensures that it will always provide high availability. So your MongoDB database will always seem to be available. And this is how you can play and set up and configure your replica set environment. Thank you.